we are in a position to start.
Yeah.
How many are there approximately?
20.
25?
Yeah, 20. So you can say 9. Okay.
Good.
So, hello, can you hear me? Hello, students, can you hear me?
Yes, sir, we can hear you.
Yes, sir. Yes, sir.
Okay, so this is the guest lecture today is Captain Sanjeev Pandey. Okay, he's taking this lecture on behalf of AIMPA, that is Indian All India Maritime Marine Pilots Association. Okay, so Captain Pandey is from TS Rajendra 73-75 batch. He started his career with Sindhyas in 86. After that, he joined KC, that is Kishan Cheleram. And then he got command there only. After that, he taught briefly at Tolani Institute, Pune. And then he went back to his first love, that is pilotage, and working at different terminals in Dahej, okay, Petronet LNG, and PPAW as a full tonnage pilot he has worked. Currently, he is working at Birla Coppers Terminal at Dahej under contract with Ocean Sparkle. Okay, so that is as far as the Captain Pandey is concerned, who is the lecturer today. He will tell you that what he is going to speak about. Okay, and then a little bit about the All India. Captain Gajanan, can you speak about your association? I think I think it will be better that if you speak briefly about your association.
Sure, sir. Thank you very much. It's a pleasure to interact with the class. Thank you very much. Thank you, MASSA, Mumbai, for the opportunity. Everyone, good morning. And my name is Captain Gajanan Karanjikar. And of course, we formed an association called All India Maritime Pilots Association. There was a space to do something for the pilots in India, pan-India basis. So you all are all aspiring, master mariners and going to be in command in next 2-3 years' time. So you would definitely know what pilot is. You sail on ships. So you know how important the maritime pilot position is with the export-import of cargo and bringing ships inside, safety of navigation of ports and safety of environment. AIMPA has identified this gap in training in MTIs. In order to address this gap, AIMPA came forth with the pilots, enthusiastic pilots like Captain Sanjeev Pandey and others, who are volunteering to take this lecture because to teach the importance of the pilot ladder. Now, you must have seen the pilot ladder since you are cadet. Maybe I presume that everybody has been on board at least 7-8 times, and you must have read the pilot ladder also at many ports. And as I would like to say at the beginning of the lecture, that many people, 99% of people don't know what is right and what is wrong with the pilot ladder. And that can be a very potential hazard to someone's life who's climbing the ladder, and it is a pilot. Because it's called as pilot ladder, so exclusively used for pilot, but also used by surveyors and again the ship's crew as well for signing off and things like that. The important ship's access equipment, which is a part of safety equipment certificate and Form E, often neglected on board, not cared for, as it's used only in the ports, not even inspected by the class surveyors annual survey. So this is an attempt, very genuine attempt, to teach you all do's and don'ts of pilot ladder, as to how to protect pilot ladder, and by way of that, you will protect the life. There have been numerous incidents in the world. Every year we lose 2-3 pilots in the world. Just by not rigging a pilot ladder properly, not securing it well, and not maintaining it well. First of all, it starts with awareness. People don't know what is wrong. So the pilot ladders are now being manufactured ashore. So all the more danger, because then that calls for just a shore equipment and being supplied without knowing the integrities of it. I would like you all to pay a very undivided attention to this lecture of Captain Sanjeev Pandey. He's been introduced very well. He's been a senior master mariner. He has a brief experience in that lecturer also. And more than that, he has been a maritime pilot. So you will hear directly from the pilot's mouth as to what is right and what is wrong. We seafarers seeing the picture from the ship side, from the ship, and you don't see the picture of a pilot ladder or the impression from the shore side. This is your opportunity to interact with him. This is your opportunity to ask him questions, ask your genuine doubts, and ensure when you go on board vessel that your vessel has a spick and span and mostly safe pilot ladder, safe access to the pilot. Without further ado, I thank Captain Ajay Srivastava for this opportunity in MASSA Mumbai. I would welcome Captain Sanjeev Pandey to deliver his PowerPoint presentation as well as the immense knowledge that he wants to share with you all. Captain Sanjeev Pandey, the floor is yours. Thank you very much.
Good morning, gentlemen. Thank you, Captain Srivastava and Captain Kalanjikar, for making this happen. This topic is, you might say, something which, like what Captain Kalanjikar is saying, it is below the radar, yet it is very important to the ships. So here we will start off with a few videos, and then we will follow with a presentation and some question and answers later. This is a brief video on the pilot ladder, rules and regulations, and what we expect you to do, the procedures.
Let's start with some indoor checks while the bosun lays out the pilot ladder for inspection. Let's see if the pilot ladder is certified. If you have a second pilot ladder, make sure that it is certified as well. There you go. As long as you're there, few more things to check. Check the plant maintenance system. When was it put into use? Check that you have an inventory maintained for the record of pilot ladders. If the pilot ladder was ever repaired, check how it was done and when. Make sure that it was inspected by class. Now, this is a tricky question. Where would you get this information? When was it inspected by class? Well, pilot ladder is part of your safety equipment certificate. The last SEQ certificate inspection date is when it was last inspected by class. There you go. That's the date we are looking for. Now that we have finished the indoor checks, let's go on deck and inspect the ladder. Carry out your physical inspection of the ladder. It should all be in clean condition. Inspect the side ropes and the wedges. There should not be any missing wedges. The side rope should have a firm grip. Make sure it is in order. That's a bad example. It should not be like that. Let's inspect the steps now. The steps should be clean. They should not be painted. They should all have non-slip surface, including the rubber steps. Check the condition of the rubber steps, that they are not cracked. Once again, they should be clean, firmly fixed. Spacing should be even. Look at that, a broken and cracked step. Make sure you don't have that. That's a very shabby ladder which could come off at any point. Make sure that the side of the ladder is marked with heights along the length. There you can see 6 meters, 5 meters, 4 meters, and so on. We're going to inspect the spreaders now. Check the condition of the spreaders. There should not be any cracks. Should be firmly fixed. Spacing should be even. Let me show you an example of a very, very badly fixed spreader that's really dangerous. So this is the marking which relates your ladder with the certificate. It should be clearly marked. The Pad eyes on deck should be color coded with SWL, unlike this one which has no markings at all. The pilot axis should be firmly marked on deck in clean condition. The duty officer must be checking this, unlike this one. The pilot ladder must be marked with tags for easy identification with your PMS. The length of the ladder should be enough to reach the water line in any condition. Now that we have finished with the static checks, we are going to go for the rigging of the ladder. Let's rig it up. The rigging of the ladder must be done safely under supervision of a responsible officer. The ladder must be made fast on deck firmly using the pad eyes on deck, using strong shackles. There should be a life buoy next to it with a line and a light, but the line should not be connected to the buoy. It should be firmly resting on the ship side with all the steps touching the ship side, and the area should be free of discharges. Look at that ladder. It's a very poor rigging. None of the steps are touching the ship side. If there is a tripping line, there's a right way to connect it. It should not be fastened to the bottom part of the ladder below the spreader. It should always be above the spreader level. The illumination of the area should be adequate, which is usually provided by the deck lights, especially the searchlight on the bridge wings. People rigging should be wearing proper personal protective equipment, including safety harness, life jackets where necessary. The pilot ladder should be firmly fastened to the ship side. You can see there's a magnetic clip over here. There can be other systems to fasten it. That's a very, very wrongly rigged ladder that can come apart any moment. Now, the height above the waterline must be suited to the pilot's requirements, and it should never be touching the water. The pilot axis should be checked by the duty officer after rigging. There should be a safe access for the pilot to come up. That's an example of a very, very unsafe access. It should not be this way. If you are connecting man ropes as required by the pilots, they should be between 28 to 32 mm Manila ropes only. Let's go for rigging a combination ladder and see what are the precautions to be taken over there. Now, if the freeboard of the ship is more than 9 meters, a combination ladder must be used. A single pilot ladder should not be used. Anyone who's involved in rigging of the combination ladder should always be wearing safety harness and life jackets. Proper PPE should be worn. Now, some ships are using a fall preventer device attached with a harness. This is extremely useful and increases the safety. The angle of inclination of the gangway should not be more than 45 degrees. That's the inclinometer of the gangway, as you can see. The gangway or accommodation ladder should always be leading aft of the ship. It should also be connected firmly, attached to the ship side. The pilot's climb is expected to be between 1.5 to 9 meters, not less than 1.5, not more than 9 meters, and the pilot must be escorted to the bridge when he arrives.
Now we'll go on to see some boarding videos, short ones. Here's one boarding in rough weather. You'll see the pilot requires a lot of skill at timing and of course some determination to do this. He's putting his life on the line over here. Everything has to be done perfectly, rigged. The ladder has to be rigged properly for best chances of the pilot getting on board without any damage or injury. I like this arrangement they have on this boat. They have some sort of a platform rigged on top where he's perched over there. So he's well clear of any effects of the ladder with the pilot board. And it reduces his climb. In a flash, he's on board. There we go. Well, he succeeded. So everybody's breathed a sigh of relief, as the pilot himself. Now we'll see what happens in the next video. Something similar, but unfortunately, things go wrong. Quite similar platform arrangement, bad weather, and here he is. That's it. That's all it takes. One small mistake and it's over. So I think a life buoy has been thrown. Here it goes, without a lifeline, without a safety line. So it's easy to throw. That's why you should not attach the heaving line to a life buoy, separate. The heaving line is used to toss to the person when you come close and to haul him on board. So now let's get on to the presentation, followed by another final video, and then we'll have question answers. So why this lecture? Well, such a simple arrangements actually, but then so many things can go wrong because there is a lacuna in the regulation about securing of ladders, which I'll explain very in detail. So today's aim is mostly to clarify how a ladder should be secured correctly, both in terms of the means of securing and its length. The correct length is also very important. Then we touch on some aspects about low freeboard pilot transfers, where it looks very simple, but things can go wrong very quickly on ships which have got a low freeboard, very small ships, tankers, OSVs, MBCs, things like that. Small tankers, product tankers, small feeder vessels, deeply loaded ships like that. So you have to be very careful there too, and we'll talk about that presently. So just too many fatalities and injuries repeatedly for quite similar causes. That's not good. It means education is required, which is what we're doing today. A 20% error rate is just too high. And this is not just something, it is properly studied by the International Maritime Pilots Association in large areas of the world. A study was done. So the root cause, as I said, low awareness of the provisions, of the governing standards, and of current best practices. So we'll be talking about best practices today. So the issues we're restricting ourselves to is improper securing of the ladder to the ship, rigging ladders excessively low, low freeboard transfers, and some particular points of combination ladders and some other related issues. So this pilot ladder rests in a system, an ecosystem consisting of a chain of systems linked together, and you know a chain is as good as its weakest link. So if any one of these links is not good or not observed properly, then you have a failure coming up. SOLAS and IMO, SOLAS is regulation, IMO is the recommendation. Both together, they talk about a standard, that is ISO, to which ladders must be built. And then you have the whole thing, to put it all into practice, is the ISM code. So let's start with the basics, the securing the ladder. We say, what's so big deal about it? But this is where a lot of issues arise. You see, there's regulations that talk about securing a ladder when it is required at its full length, the supplied length, whatever is supplied to you, the full length. The lower part of the ladder is open, that's the lowermost step, and the upper part, the top part, ends with two thimble eyes. So the regulations say, attach those thimble eyes to designated strong points on the deck near the transfer point, and use shackles. And pay out the ladder over the side, and there you are. So all the weight is taken by the side ropes, which are the strongest part of the ladder, and that's how the ladder is meant to be. Take the weight on the side ropes. Only thing is, the length, that is the lower step, may not be at the height required by the pilot, and therefore you have to adjust the length. This adjusted length is called the intermediate length. And how to secure a ladder so that it hangs at the intermediate length? Unfortunately, there is no specific thing mentioned in the regulations. So over a period of time, seafarers being very resourceful, they've come about all kind of methods, and which we pilots and various associations of pilots have done some study and come to a conclusion that there is only one method which we recommend now that ships follow, which I shall talk about in great detail. All other methods should be avoided. They have all kind of issues. One thing I would like to point out is that ships can no longer carry out repairs to the ladder on board, other than replacing a particular broken step or even the spreader. But the replacement has to be done by a part which has been supplied by an approved manufacturer of the same ladder. You cannot just get something or make something on board and fit it to the ladder. You cannot re-seize or reclamp the fixtures which support the steps. You cannot do that. You cannot put any splices to repair the ropes. So in short, other than doing a replacement, simple, that is a broken step, take it out and put a replacement step, that is from a certified step, there's nothing more you can do. So it goes to show that if you damage the ladder by improper rigging, then at the next port or even for disembarking, the pilot will refuse to use that ladder. In fact, you should not be rigging it in the first place. That is what it means in the word rigged and supervised by a responsible officer. A responsible officer just does to have a cursory look and that's it. He is supposed to have trained the crew, the procedures, to ensure that they know that any defects are there in the ladder, those are pointed out, and then the responsible officer will make a judgment that this ladder is usable or not. And you have to take the hard decision of not using a ladder other than putting out a defective ladder for the pilot. For something to happen, it is easily found out whether damage is existing or occurred during the current transfer. And if it's found as a pre-existing damage, you're in trouble, as it should be. So something which your procedures caused, poor rigging, poor securing, you damage the ladder, and now you should try to cover it up. Not good at all. Ultimately, we have to work as a team. The pilot is there to help your ship. It is not to be, his safety should not be compromised in such manner. So some of the defects in the rigging is like this, which you understand with pictures. So there's something called a deck tongue. It's like a short, small angular bracket which you weld on the deck close to the edge, and you can hook the ladder step onto that. That is not good. All the weight comes on those chocks which are seized onto the side ropes, and the seizing is just by thin marlin or just by flimsy clamps. It's just enough to take the pilot's weight, not the full other forces which can be exerted. Not allowed. The one on the left, a splash or wave, can unhook the ladder and dislodge it. Then left side, securing to undesignated points. In this case, on the left side, is secured to the ship's railing. Railing is not meant to withstand the forces which the ladder can be subjected to. Not good. Alternately, some ships, while railing, they can find the nearest pipeline or some pipe vent or anything. Sharp edges, sharp angles, all undesignated points shall not be used. But on the right is shackles. Shackles is a very notoriously common thing. It looks very convenient, looks strong, but it has issues. Again, not allowed. The issues with shackle is it damages the rope very quickly. Once the rope is damaged, remember, you have to replace the ladder. You cannot repair it. And you can't just get ladders quickly. You have to be helicoptered, brought to the pilot station. Big problem for you if that were to happen. You found out that damage was caused by shackles. Ladders don't get damaged on their own. They get damaged from use. From misuse, like this, by shackles, they will get damaged. Another creative way is a platform to allow a safe footing for the pilot, but the pilot asks the crew to open it up, and where is securing? There is no securing a ladder. The ladder was basically just kept by the locking pins on the platform. Those 2 pins on the side you can see. Again, not a good method. Here again you have used a crossbar on the left side through 2 eyes, something similar to a bracket. The effect is the same. All the weight comes on the step chocks, which are not meant to take weight other than just the pilot's weight. And forces can be much more than the pilot's weight. Here on the right, they use the spreader to be braced against the side railings. Not good. Then they said, well, as an additional safety measure, they applied 2 shackles, which is also wrong. So, how do we secure the ladder at intermediate lengths? The rolling hitch. Why? Because the ropes, side ropes, are the primary weight-bearing part. So, the rolling hitch method takes into account this fact. Side ropes are made of rope of a minimum breaking load 24 kilonewtons, roughly 2.4 tons, whereas the steps and the fixtures, that is the chocks, on which the steps rest and the fixtures are attached to the side ropes with clamps or seizing. Now that system is proof load tested to only about 8.8 kilonewtons, that's about 900 kilos. Pilots weigh about 100 kilos at the most with a bag and everything. So then to account for some jerking and safety margin, 900 kilos applied, but this is still nothing compared to the strength of the side rope, which is 2.4 tons, almost 3 times stronger. So the rolling hitch, which is applied onto the side ropes, grips them and takes the weight. And while gripping, it does not repair the side ropes. The shackle will very quickly. One pinch and hard, the rope is damaged and that ladder is unusable. So here is what we are saying. Ships, those who don't have it, can straightaway use a suitable piece of rope of at least the same minimum breaking load as the side ropes. Good rope in good condition, preferably with a certificate to back it, and tie one end to the strong point on the deck and the other end apply a rolling hitch onto the ladder. Ensure that both the side ropes have got equal amount of length of the securing rope. If they're unequal length, you'll find a slanted ladder. And since you're going to do it repeatedly, and since these securing ropes should not be used for any other purpose except securing a ladder, because the same amount of care you have to take of the securing ropes as you take for the pilot ladder. Pilot ladder nowadays have to be certified, everything. So the securing ropes also have to be certified. It follows logic. So here they suggested that you make a strop like this or order one from suppliers with specifications of the rope being the same of the strength equivalent of the side ropes. Put a thimble eye and onto 2 shackles which are certified, and you keep this as a kit and stow it away in the safe inside the stores, away from the weather and any damage from chemicals, etc. So you just shackle it onto the strong points, and the other end you put rolling hitch onto the side ropes, and there you are. So in pictures, this is how it will look. Rolling hitch is a very simple hitch, very quickly you can learn, very easily taught. Lots of little videos available on the internet, how to make left hand hitch, right hand hitch. Just you have to make sure that the length of the secured ropes is equal and that you ensure that the knot is properly gripping. You sort of tighten it up. You try to tie a very loose knot on the rope, it will not be effective. You must tighten it up. So now I will go on to the next point of securing ladder at the correct length. I have got a better slide than this. That better information is in Word document. We'll switch to that for a moment. Here. This can be seen by you properly?
Yes, sir.
Okay. So this slide I'll explain in some detail. This is damage due to rigging ladders too low. The typical thing is, okay, you get information from the VTS or from the pilot station, how many meters above the water the pilot wants the lowest step to be. So suppose it is 3 meters, and then the order goes to the crew, rig the ladder on so and so side, 3 meters of water, and the crew goes and does their job. I suppose they put on all their, they do a risk assessment and so on and so forth, put on their PPE, and they go about doing their job. Fortunately, because of lack of knowledge, what happens is the ladder is put over the side, and somebody, maybe the bosun, somebody, you just have a quick look over the side after it's set. Okay, it looks to me visually 3 meters, it's fine, and then they secure it. Somebody means, well, in that, suppose the ladder is too short, maybe we have to again come back on deck and adjust it. So let's put a couple of sticks extra out anyway. And in last minute, when the pilot comes, we'll just use the tripping line, there's a retrieving line, to pull up the lower part of the ladder so it doesn't foul with the pilot boat. And then when the pilot is about to step on, we ease on that tripping line, and there you have the transfer taking place. Wrong. The tripping line is not meant for that use. It is meant for only securing a ladder after it is used, to retrieve it. It's a retrieval line. It is not an adjustment, length adjustment line. Why? Why am I being so particular? Here, if you understand this point, then you will ensure that you rig it at the correct length. You take the trouble of taking the correct length. It will preserve your ladder. It will go a long way in ensuring the ladder doesn't get damaged. And I cannot emphasize more and more that you cannot use an unfit ladder, cannot repair it on board. And it's not easy to get replacements at short notice. A lot of delays. So best is rig it properly. Take some trouble. Understand this point. So over here I'm showing figure 1. The ladder over the side, a bit too long, you can see, and a pilot boat in the waves has exerted. It rolled onto toward the ship and jammed and hit the pilot ladder. Bump force. I call it bump force. Bumps hard. So in this picture here left, I have resolved this bump force BF into horizontal and downwards. This downwards one is the one which is causing all the havoc. Now this force is much greater than just the 900 kilos proof load testing of which is used for the steps. This can go up to much more. Okay, you can even part the ropes, but hopefully not. So this bump force acting on the ladder here on top, where does it exert? Here we can see on deck this visual from top view, bird's eye view. The ladder secured on deck with 2 shackles. This is a non-compliant way. Okay. Now, bump force won't act equally on both the ropes, side ropes. This is one side rope, second side rope. More likely, one of them. In this example, I said assume that it acts on this side rope. That is this one. What happens is a huge bump force, downward pull, BD one. It yanks this down, such a sharp tug. What happens? This step remains as it is, but this fixture which is there, seizing gets torn out. This seizing gets torn out, and the rope gets pulled out. When it gets pulled out, all these steps, this part, they come closer. these remain as they are because this has not been pulled out. So then what do you have? The ladder, what does it look like now? You look like in figure number 3. This is how it was, nice and straight and parallel before the bump acted on it, and afterwards when the bump acted, the securing point on top, it got damaged, so the entire length of the ladder has now become sloping. How can the pilot climb on such a ladder now? One bump is all it took, and that you have now. Your whole entry or departure as a disembarkation is cancelled. Not good, not good. Can you imagine turning a ship around at the last minute? Maybe if you're lucky, if you're not reached abort point, and pilot says, well, it is damaged because you rigged the ladder too long. Another one could be, maybe you didn't get damaged over here, but this particular step can get damaged, localized damage. This can also happen. This is not so troublesome, but this is bad. It can happen. A shackle will do this. So this is a localized one, and typically when we see in further pictures, this is what happens when you see ladders damaging. There is no way a pilot weight can do this. It's always extra long ladders being yanked downwards by pilot boats or following it there, and this is what the damages suffer. The sloping, slanting is all by pilot boat damage, and the root cause is rigging the ladder too long. Now let's go back to the presentation. So what is the remedy? Rig the ladder the correct length, not just by a guesstimate, but by a precise measurement. How to do it? Nowadays ladders have got markings at 1 meter intervals. You can see the markings here. Use this. It's a very nice thing to have. If you don't have markings, if you don't have, it doesn't matter. You can always devise measuring rope or tape or something, but do it properly. Measure it. Basically, make a calculated rigging. Don't make a guesstimated. Guesstimate thing can lead to bad consequences. So here, suppose the distance from the top step, that is from the deck edge to the water is 12 meters, and height desired by the pilot above water is 4 meters. So you have to rig it 8 meters long. But how will the 8 meters be determined? By using this measured length. So if you measure it out, you can't go wrong. Then you go on to say that what happens when you are using a ladder on a shipside door or suspended from under a combination platform, the trapdoor kind of arrangement. So those require a special way of calculating, but it can be done, and it should be there in your safety management system. If it is not there, think about it, and you are now doing a senior officer's course. You can always tell the office, this is what a risk analysis is showing. These consequences is not good. So I think this we need to improve on our safety management systems for rigging the ladder at the correct height, and this is what we propose. Like say, for example, the gangway, what is the angle at the gangway, and under which a fixed length of ladder is suspended, so that the position of the lower platform and the ladder hanging underneath it together by calculation, depending on sine theta of the angle of the gangway, you can calculate, and then you can find out exactly where the lower step is. That kind of precision should be there. So if you do it on a basis, you're always stand in a good stead on your, if anything were to happen, you say, well, how do you ensure the correct length? So this is what a procedure which we follow, and nobody will point a finger. But if you say, I just told the bosun and he did it and we didn't know, and then yeah, tutu meme, not good at all. So the tripping line, like I said, is only for recovering the pilot ladder after the transfer is over. It is not meant for temporarily adjusting the length of the ladder. And it should lead forward to avoid fouling in the boat as it approaches for transfer. The rules require that it be secured at the lowermost spreader close to it and above it. So here, damage to the pilot ladder, you can see I'm talking about. Here you have this one being ripped down, and this is why you have a slanted ladder. This is not so bad, but it can be worse. A tripping line This is what I'm talking about. Trying to adjust the length, not good at all. Bad seamanship all around. Here again, localized damage, like I told you. Doesn't happen by the pilot stepping on it. We all have pilot board damage. And here is an extreme case, like I said, the force doesn't act uniformly, it's acted more on this rope, enough to part it. As it is, the rope is not in good condition, but the shackle is here, nipped it hard, like a knife, it cut through. Low freeboard. Looks temptingly easy for the pilot just to hop off and hop on, but in a flash things can go wrong. This is of an actual photograph after an inquiry in London where a pilot died. He just came here and just stepped off. This judge, boat was bobbing a little bit and he stumbled and he died. Injured, fell on and whatever, he died. The details I don't know, but it's a fatality. Just 800 millimeters, about 2 feet, that's all. What the inquiry said essentially was they should have used the ladder rigged up this way. You can see the animated ladder here. So that, and of course, they should have had a step, bulwark, railing ladder also here. So he climbs up, goes on top of this, then you have 2 man ropes rigged on this, turns around, holding onto the man ropes, then he steps down one by one, and then he times his transfer onto the pilot board. So at all times, he's got a 4-point or 3-point contact. Over here, it's a hop. That means you've got no contact anywhere. Maybe at most 1 hand holding onto the ring, but 1 hand free and two legs free, you're hopping off. You're totally bad way of doing it. So this is what they recommended, that you have 2 designated points. This is not a way to rig the ladder onto the railing. The ladder will be rigged here onto the deck. He climb up. Railing can be used as steps because there's no weight coming or pilot coming in. Stepping on it, there's no problem. And then he steps onto these 2 steps and he gets onto the boat. So ladders to be secured here onto strong points. A step ladder to be put, so he climbs on top. Man rope to be put onto this and holding on man ropes, using the railing as steps, and finally go into the last 1 or 2 steps he requires and go onto the boat. Well, this was one suggestion. It is all some common sense. The point here is don't take it lightly. Hopping across has been proved fatal. This is not. You have to somehow make an arrangement where you have 3-point contact. What I could think of is you climb higher up, and if you have tall stanchions with man ropes, you can have a handhold all the way down. Here is an example, taking a little shortcut. Suppose they had those 2 tall stanchions and man ropes. This pilot would be holding it much higher. His hand would be here, so which is well above his center of gravity, so he's not toppling over. Over here, his hand is very close to his hip, which is close above and below his center of gravity. It is toppling him. Very dangerous. But like I said, sometimes people take shortcuts, and that's where issues occur. Nothing happens when everything goes fine, but something goes wrong, then you are in trouble. So I would highly recommend that if you are on these small ships, take care, don't take it lightly. So now combination ladders, why the fuss? You must understand, it is the height from which a pilot can fall, and some consensus, medical consensus is there of probability, whatever, that the damage or injury to the pilot, it can be lethal if he falls from a height which is more than 9 meters into the water. So this table on the left shows you the acceleration by gravity and the speed at which you will hit some surface from falling from different heights. Even from a 1 meter height also, by the time you hit the water, you'll fall at 16 kilometers per hour. It's quite a hard smack you'll get. And from 9 meters, you land up at 48 kilometers per hour. Is as good as hitting concrete. So 9 meters is a turning point after which you have to rig combination ladders. And then there's some confusion about fall height and climb height. The SOLAS has used some words. Sometimes the language, English is not a very first language of many. So if you understand well, you will get a good grasp. But if you're not, English is not very good your strength, you can always make a misunderstanding. I'll just clarify that. So it is the fall, not the climb. So in the earlier example, 12 meters is the height of the ship's deck above water, and 4 meters is the height above water which the pilot wants a ladder. So 8 minus 12 minus 4 is 8. So the pilot has to climb only 8 meters. So then somebody might think, "Alright, 16 में तो climb लिखा है, so okay, 8 meters, so good. I don't have to rig up combination ladder." It's not that way. Okay, it's the fall, because the pilot can potentially fall when he's just at the top of the ladder, and then he's going to fall for the full 8-meter length plus the 4 meters height of water. 12 meters he's going to fall, even though he's climbed only 8 meters. So it is the fall which matters, not the climb, for combination ladders. Whereas for low freeboards, when the climb is less than 1.5 meters, the pilot ladder, in fact, the Zola says you can do away with the pilot ladder. It's a strange regulation. So combination ladders, you all have dealt with them on board. So I'll just touch upon some common defects. Care should be taken that these things don't happen. First one is, say, the lower platform is overlapping the ladder. Can you imagine pilot trying to climb up over here? He doesn't know how to pass his hand up above, and he can't get up. Very hard to transfer. Absolutely wrong. This gangway has to be lowered further down so that it doesn't overlap. Probably they can't do it because you have to meet the 5 meters height limit. So this is the wrong arrangement. The ladder in this case should have been shifted half meter or so further aft. And if that is not the case, there's only strong points, only these two, then that means they have to fit 2 more strong points and say, for this angle or this kind of freeboard, this is the point where you have to secure your ladder. This is all have to be fixed up in your SMS. You have to make these changes. You have to take the trouble. You cannot just say, yeah, okay, just one small thing, pilot somehow will get on. It's okay. You can squeeze past. That is wrong, not a good approach. Over here, the tripping line is lowered, secured too low and is leading aft. The pilot boat will foul this. Here the ladder is not secured at the correct position. It should be secured about 1.5 meters above the lower platform. Such a low position, the difficulty, you try climbing up a ladder like this and down the ladder, you will see exactly what I mean. Saying it is something and actually experiencing it is different. So with my experience, I can say it is not good for climbing or descending. The right hand side picture, you can see that the ladder is secured at a higher place. So allows the pilot to go up. So you can see how high he has to go. His leg has to reach the level of the lower platform. Till then, only then he can transfer. So that's why the ladder must be secured at least 1.5 meters above the lower platform. And the lower platform itself is secured separately to the ship side. There's some good riggings. These trapdoor arrangement platforms, that is the ladder is suspended under the platform itself, lower platform itself of the gangway. That's quite a unusual or sort of a not very well thought out. The trapdoor itself is problematic, and the whole arrangement now, if the pilot boat force, the bump force, were to act on the ladder, which is maybe rigged too low, then you're going to pull the whole weight onto the falls of that trapdoor or the lower platform, and you don't know how strong those falls are, whether they can withstand the weight of a pilot boat weighing down on them. Unlike the separate combination ladder and ladder, at least they are 2 separate units. The whole gangway won't come down. But the other one, which is one unit, not good. In any case, that unit also, I've seen very often, doesn't have any securing arrangement. It doesn't get secured to the ship side often. They're saying, well, it's got so many falls, 4 legs falls are there. It won't move around. It does move. Bad rolling, it does move, and it's not good at all for the pilot to be hammered back and forth while climbing up an unsecured system. So that also is a flaw in the trapdoor arrangement. So we'll go to some other finer points. We have different arrangements for large freeboard ships or very large ships like say high freeboard ships, especially these ultra large container ships and ro-ro ships. So they have these side doors or even winch reels to rig up the ladder to help the crew. Otherwise, it's going very heavy. Only flaw is now the winch reel must not take the weight. The ladder must be secured to the strong points on deck. Rolling hitch again. So those ships, you go on board, you don't have that securing points over there. You must get the securing points made, and rolling hitch strops made on board, and eventually properly certified, supplied ones we indented for. Then you must be securing the ladder properly to the ship. And no weight coming on the winch reel. Winch reel should be locked in position and power, air or electric supply isolated. The drawing on the left, this is to be corrected. This is not correct. It's not a pad eye. It's just a leading kind of a rope, a leading eye. This drawing is not conveying the correct meaning. What I say is this should be a pad eye and it should be secured with rolling hitch. No weight. This rope should be slack. Here it is. What I was talking about. Rolling hitch should have been applied. This is a strong point. Maybe here. Thimble eye one end, other end. Rolling hitch on this part, or this part better, and tighten up equally. No weight on this. No weight here. Same thing over here. Different kind of arrangement. A long sort of a trailing rope is there before a ladder hanging on the side. This is also, like they say, is led up like in the AIMPA poster. This is what I'm talking about. This is wrong. It should have been again a securing strap with shackle and rolling hitch tied over here. No weight on the winch. Hull doors. Rules say you cannot open outwards. And again, if they have a winch inside, again with no weight coming on the winch, you should ensure that you have arrangement to secure the ladder with rolling hitch up to 2 strong points. The left hand one, here you can see ladder just like a combination ladder. This ladder here also should be secured about 1.5 meters above the platform, secured to the ship side to prevent twisting and moving around during the transfer. This is what the photo is showing of the ladder required to be secured to the ship side to prevent it from oscillating and swinging like a pendulum. Only thing is, in this drawing, they have secured it too low and only one rope is secured. This is guaranteed that the pilot is going to have a very bad mood when he tries to come up. Because even this person watching, he'll see the pilot twisting and turning around or ladder almost flipping over because only one side is secured and that too low. This should have been secured further up, 1.5 meters above, and both should have been secured, this rope as well as this. That would have been a good transfer, pilot would be in happy mood. So, trap doors. The issue with trap doors, why I'm pointing this out is, this is something which our efforts are on to get all these defective things to be replaced with the proper compliant ones, or better, because you can't really say they're non-compliant, they are very bad. By accidents and fatalities, they've been proven to be non-compliant, even though pilots have been complaining about this so often. Sadly, it takes a death for people to wake up and start deciding doing things. Only now, lately, some shipping lines have started doing it on a fleet-wide basis, but still, it should not be that way. Now you go on board, you should try and get these things changed to the more suited ones. You try climbing up this, so far okay, you're able to grip on this, but how do you go across this channel bar and these horizontal pipelines, piping here, which is very slippery, not good. A grip on a vertical rope is far, far stronger than a grip on a horizontal fixture. So it says that this pilot ladder should continue further up for 1.5 to 2 meters at least, and then pilot should be able to transfer onto the platform. You can see the pictures over here, Let's go further. So this is a good arrangement. See, it's gone all the way up further. Of course, this is a separate unit. This is not part of the platform. Here I'm talking about, this is the part of the platform, is this ladder suspended from this whole contraption. Here it is separately attached to the deck and the platform is just placed around it. See, here is secured to the ship side, 1.5 meters above. So this is a good arrangement. Over here, of course, the ladder itself is going up. It's going into a U-shaped kind of frame. That's how you can get a good grip. One ladder all the way, no transition to some funny kind of point handholds. And this is a good arrangement. Only thing is, this whole contraption is not secure to the ship side. I'm very worried about this. In rolling, this whole thing goes back in and out and slams hard. Not good at all. So some associated equipment, we are almost finished. Associated equipment. So the amendment to the resolution about associated equipment. It says that now the step ladder, the bulwark ladder, and the stanchions should be separate, not combined into one unit. Man ropes to be put up and placed over the side only if required by the pilot. They can be kept ready in case you are in doubt. You can keep them ready, rig them up to the same height as a lowermost step, and then bring them back on board. If the pilot wants, then you can easily just bring them down, lower them down. If you don't want them, no problem. They're always there. But at short notice, you want to start running around and you want them, it's not good. So have them rigged if you are not being specifically told. And one point I want to mention before we go further is that sometimes, we make an estimate 3 meters above water level, but when the weather changes or worsens, or we find that the different boat is allotted to the pilot, which has got a different height above water last minute, so then or some communication gap is there, whatever reason, in the last minute, the pilot, when it approaches the ship, tells them, no, please lower the ladder 2 steps or raise it 2 steps. And then people start grumbling and they start using the retrieving line. That's not good. Your ship's crew should be available in sufficient number during the transfer. That's what your SMS procedure should show. So that when such a situation arises, shortcuts are not taken, the ladder is properly, again, re-rigged to the correct height. You can just say, okay, the boat can tell you 2 steps up, 2 steps down. That's very easy. You don't have to go to the measurement process all over again. So 2 steps up or down, that's exactly what the crew should do. So you should have not just one officer going on deck to receive the pilot. It should be sufficient crew to, in case the last minute adjustment is required. So some other things which you might find here on left hand side, the securing points are so close to the ship side, you don't know how to secure that. How will you put rolling hitch? You have to, first thing you do if you go on board a ship like this, get this thing shifted properly here and certified. These points should be approved to a certain safe working load and then put in use, marked, and this one to be decommissioned. The right hand one is okay. The ladder ropes are protected from a wire, falling with this wire with this guard, and also sharp edge of the ship side by this kind of a rolling curved protection piece. This is very nice. This is what we are talking about, not really about securing. This is also useful to have. If you don't find this there, you can get it fitted, something like this, to protect your ladder from damage. Safe approach. what we saw in the video. Here we can see a picture. A pilot boat can get hit very badly by when it rolls or the ship rolls, and it can damage the boat or even capsize it by this thing grabbing or catching the edge of the pilot boat. So this is a very small gap. They want at least 6 meters. So then the more reasonable within the ability of the boat to maintain position during a transfer. 6 meters is what is most capable of within capability of most boat handlers. Well, why should a gangway be leading aft? Here's why. Because here we have a fall which parted. Because leading aft, when it fell out, it swung forward, clear from the pilot boat. If it was leading forward and the pilot boat is coming from aft, and the fall were to part, the whole contraption will come and crash onto the pilot boat. So here we come to the end of our presentation. Now we'll go to another video to conclude, and then we will take some questions. This is of how people think they know their job, but they don't. Watch. Again, boarding in rough weather, in a Disney fantasy. Ladder is way too long, isn't it? What's happening to it? Fouling, damaging, pumping. And what are the crew doing on top? Just watching. Lifting around the ladder with your hand, well secured. The ladder is secured to stanchions, the eye is on the stanchion, that's where it's secured. This is a joke. This ladder should have been secured on deck on strong points with rolling hitch, and these stanchions should have been separate. Plus, these stanchions are not supported at 2 points. They may be fixed at the bottom, they should be supported over here also. So many things are wrong over here, and nobody has done any corrective action. They're all in a blind zone over here on the ship. Okay, all very particular about the uniform, very nice, but what about the seamanship? Not good at all. Lack of knowledge. And I would say the pilot, maybe say charitable to him. If I were him, I would have refused. It's easy to refuse, but hard to do. He must have thought, well, it's just a few steps, I'll get on board, and then I'll tell the crew what's wrong. Otherwise, they will be complaining that for some no rhyme or reason, he didn't board. It's just a matter of a couple of steps, something wrong with the pilot. This is what the kind of thinking I'm with. Practically, things can go wrong very fast. Over here, let's see what happens. Is he bored or not? And it is. So, it makes new headlines. As far as I'm concerned, this is a very bad headline. So, that concludes my presentation. I will stop sharing. And thank you all for listening in. We have some time, we can have some questions, or require some time to think what has been talked about. Some questions.
Anybody has any question?
I'm sure they will all have.
I can't hear you somehow. Oh, it's gone off. Okay, my speaker
Sir, my question is, sir, why these this pilot ladder rope is always Manila? Just for this friction reason or anything?
Yes, for friction reasons. It should be some non-synthetic fiber, better grip. You're talking about securing rope, no? I sorry, I didn't get the first part. I assume you're talking about securing rope, no?
Oh, side ropes.
Side rope. Yeah, the ISO standard now recognizes a lot of synthetic stuff available. So it's ISO standard. Manila is the traditional fiber. but it is given approval to many synthetic kind of fiber. It's got a lot of technical specifications written into it. If you see the ISO standard, that's what the ladder should be made of. And actually, we should not be bothered about this because nowadays you have to buy the ladder from an approved maker, and the approved makers are all certified by class or by the Maritime Administration, so that they comply with the ISO standard. So, in any case, you can't repair them on board. All you can do is replace steps. So, you should not be really too concerned about what it's made of, as long as it carries a certificate. That's very important. It has to be certified, marked with the tags, and identifiable, traceable. That's what the ISM system requires. When was it brought on board? When was it put into use? 30 months is the limit at which you can use it. All these things are specified now in the SOLAS as well as the ISO standard. The frequency and periodic inspection, testing, maintenance, pilot ladder also very much there now.
Also, two more could be the very common sense reasons for the Manila rope is, that early warning of breakage is given by Manila. And second thing is that, when you inspect the ladder every month or before the use, the brittleness of Manila rope is more visible. The signs of wear and tear are more visible on Manila than on the synthetic fiber rope. So ISO 799 also says Manila. So that's good common sense reason.
No, I will also say that these synthetic ropes now, to get over this problem of maybe crew doesn't know how to determine whether a rope is deteriorated or not because they're not familiar with the synthetic kind of fibers. So what the standard says is it's got a core of a different color. Now, if that core starts showing at any place, because our core is worn out or frayed, if that core starts showing in any place, that rope is to be condemned. I think ladder is condemned. So it's a visual indication you get, very positive indication. So this is all there in the ISO standard. And as I said, the maintenance procedures will guide the crew or the manufacturers. You can tell them, ask them that how am I supposed to know if the ladder is deteriorated or not. So the manufacturer should be able to supply you with guidance, and that's what your quality management system requires, that the ship should be provided with the necessary information and not just be based on some thumb rule or some basic training given in the institutes. Nowadays, technology keeps advancing, so you have to keep abreast. That's what your ISO system is about. Cannot be, okay, Manila will be going for hundreds of years, so everybody is familiar with Manila. So you teach them Manila, and then you don't tell them anything about synthetic ropes. Yeah.
True.
Okay, sir.
Any more questions?
I have seen the securing of the pilot ladder. Regarding that, I have seen there are magnetic clips. Those are used. I think that is a good arrangement because even in the slight rolling, the ladder will stay firmly along the ship side. So regarding those magnetic clip, is it any regulation to carry those? Because I never have seen in the tankers. I mean, those ships I have sailed.
Well, it is your method of securing. Like if your tanker has been provided with dedicated recessed sockets, so then in that case, at different locations, so it's 2 or 3 standard heights or angles of the lower platform, those sockets are usable. Typically, large ships have 3 sets of sockets. You require 3 sockets per one rigging, so you have 9 sockets planted at different heights above freeboard and angle of lowering of your gangway. But absent those sockets, then you have to use these magnetic devices, and definitely they should be available on the ship. Maybe on your tanker, maybe one particular rigging or one particular kind of fixing, they never required, or all along they have been preparing the ladder in a non-compliant way. If you say they're not available, then you should investigate. And definitely, the rigging procedure is not compliant, and first thing you should do is order for these magnetic devices and start using them. And they are from these different kind of approved suppliers. So it is not just any old magnet you get from here and there. So they are pretty much tested and approved and by various maritime associations, administrations. So those are the devices you get, and they're very good, very effective. They're not taking the weight, they're only preventing the ladder from oscillating in and out or going back and forth. They're not weight bearing, they're only to prevent oscillations. The weight is taken by the side rope.
Okay, any other question?
Okay, got it, sir.
Sir, some ports do not allow the use of tripping lines. So is there any regulation pertaining to the use of tripping lines as such? Because if tripping line is not allowed, then it's very difficult to retrieve the pilot ladder from such depths.
Well, I've seen crew use a very nice device where they're not allowed to attach the tripping line to the ladder because of port regulation. Then they lower something down with a hook. So a hook fishing, like a big fishing hook, and then they dangle it over the side and hook it on to the lower part of the ladder, and then you pull it up.
S hook, yeah.
Yeah, S hook or something. That hook it on.
See, understand the hazard of tripping line, Most of the ports don't let them use you because of the tripping hazard itself and entangling hazard with the boat, So that is very important. If it is rigged properly, I don't think any port will object to it. If it is on the top, the first spread arm from bottom, and then it is on the forward side. Even IMO poster has got a clear indication of tripping line. So unless there's an incident history with some port where they wrongly rigged, this thing is there, then of course it will be a issue with the port control. Let you use that.
If the pilot takes a photograph of the crew pulling on the tripping line and making into some sort of a bite because it's rigged too long, that we put up on various PSC sites. This is exactly what we don't want. Tripping lines to be used for last minute, adjusting the length. Maybe that's what happened, fouled with some boat somewhere, and they say, okay, the tripping line not allowed in this port. So they must have had found this too often. They just simple rule: don't have tripping line.
Okay, any other questions?
Yes.
Very good, excellent.
Well, thank you for this opportunity, Captain Srivastava and gentlemen.
Thank you very much, sir. The lecture was very informative. I think I've heard from the pilots that doing pilotage is maybe an easier job. Boarding the ship is a difficult job.
Yes. Yes. Half the job.
Irony of the whole situation is that every pilot has to go to the pilot ladder and make a decision whether he has to put his life in danger or not. So that is what AIMPA is trying to avoid, situation for pilot and decision making, where if it is governed by the standard operating procedure, the entire rigging process and checks and balances, and the pilot can, blindly climb up the pilot ladder, because there's a lot happening on the pilot's mind also with respect to navigation when he climbs the ladder or when he disembarks. Statistics show that there are a lot of accidents happening while disembarking with the pilot. So, cumulative factor, of course, if he is assured the ladder is going to be rigged. Now, I'm sure that, 18, 19 plus number of students in this class, at least 18, 19 ships will have lifetime, the correct pilot ladder. That is the achievement of this program today. And at least, with this small drops, we can create an ocean of safety around the pilots, please. Thank you.
Okay, thank you very much, Captain Pandey and Captain Gajanan.
Thank you.
Okay.
Thank you very much. Thank you very much.
Just a moment. Captain Pandey?
Yes.
My interior. I would like to talk to you to thoda number milna mangta hai mere ko. You gave it
Sure,
to
sir.
Right. Okay, you want to continue?
Hi, sir. How are you?
Mainkar. Long time no see, yeah? I remember. Okay.
So just thoda number de do. I will talk to you later on.
Okay.
Sir.
Okay, so we will log off now. I will log off.
Yes.